All right, so if I asked you to make a X and Y chart for this, you should be able to do that by now. This is actually last chapter. This is what we did in chapter 5. So if I put a 0 in, anything to the 0 power is 1. If I put a 1 in there, 2 to the first power is 2. If I put a 2 in here, 2 to the second is 4, and so on. If I put a -1 in, we remember that anything with a negative power doesn't actually change the sign of the number. It just makes the 2 go to the denominator, so that turns into a 1/2. And same thing if I had a -2. If I put a -2 in for x, that would kick it down to the bottom. Notice it would still be 2 to the second power, which is 4, so it would turn into a 1/4. If I graph that, just a real quick sketch of it, 0, 1, 1, 2, 2, 3, 4, -1, half, -2, getting closer, and it's just going to come like this. And we know there's an asymptote from last chapter at y equaling 0. Now, what if I asked you to do the inverse? Well, what does inverse mean? Come on. Someone help me out.
It's sort of like the opposite.
Okay, so I want to be careful. If I asked you what's the opposite of 2, what would your answer be?
-2?
Right, so inverse does not mean opposite, okay? Opposite means you change signs. What does inverse mean? Switch
The x and the y value.
Switch the x and the y value, right? So look at this. Look at what if I had log 2 x equals y. Why is this actually the inverse? Well, right here you're not going to be able to see it as easy because it's in what form? Jonah, what form is that in?
Log form.
It is in log form. Thank you. Like I said, I'm going to start, you know how I do this. I'm going to start calling people out. If you don't answer, I will be removing you from the meeting. So it is in log form. So right now you can't see it, that this is the inverse. But Noah, you with me? Noah Brown, you back? Remember if I talk?
Yeah, I'm here. My fault.
All right. If I, what form is this in? She just said it's in what form?
Log.
What form could I change it to?
Is it called power?
What'd you call it?
Is it called power?
Yeah, power or exponential. Do you remember how to do it from Friday?
I know it was something with, didn't it have something to do with the
What's our base?
Isn't that the 2?
Yep. The power is what it all equals. So which one is the power?
Y.
Equals
X.
Now look at these suckers now. What did we say the inverse is? When you legit just switch the x and the y. Look, this was 2 to the x equals y. Now it's 2 to the y equals x. But it was written in this form, right? Because we have the y isolated, which is what we normally do. But really, this right here is the same thing as that. And that is the inverse of that. So if I take the x and y chart from here, and I rewrite it now, 1, 2, 4, 1/2, 1/4. What did I just make all the x's? Janina, where did I get that list from? Janina? Ashton? Where did I get those numbers? Where did I get those numbers from? How did I get these numbers so fast?
Of the original.
Yeah, I just took the y from here and I copied them down, right? What am I going to put in this column right here?
The x is in the original.
So what would it be?
0.
Yep.
1.
Yep.
2.
Yep.
-1 and -2.
Perfect. All the guys from over here, I just switched the x and the y, and now this became my x and that switched to my y. And if I look at the graph, it's 0, 1. Sorry. It's 1, 0, 2, 1, 4, 2, a half over, down 1, over a fourth, down 2, and it looks like this now. Now, what do you notice about this guy? This is our what? Daniel? What is this now?
That is
What was this?
can't think of the name.
Starts with an A. We chase them all day long.
Absolute.
That's our asymptotes.
Asymptote, yeah.
This right here is y equals 0. But when I switch my x and my y, not only do I switch my x and my y on the chart, instead of being y equals 0, it becomes x equals 0 as my asymptote. Everything switches, even the asymptote. So the x switched, or the y asymptote switched to an x equals.
All right.
All right, so that is kind of what we're graphing today. And just like we have done in the past, all the stuff that we've done in the past still applies. If we say f of x equals log base 2 x plus 3, because this thing is in parentheses, this would move it to the left 3. And remember, my original or my parent function for this would be log base 2 with just an x. So if I took my x and y chart from this one, which is what we just had up there, it was if I wanted to do this right here, I could take this guy applies to that. So if I wanted to do the x and y chart for this guy, everything would be moved left 3. So that means instead of being 1, 0, it would be -2. Whoops. It would be -2, 0. Everything I taught you in the past still applies. Log base 2 x minus 2. What would this do? Be careful. Orest, what do you think that would do?
Shift it right too, right?
Careful. Is it inside parentheses, Orest?
No.
So what would that actually do?
Down.
It would shift it down to. Remember, inside parentheses moves it left and right the opposite way. I think outside moves it up and down, which brings me to my next point, which we need to make sure we understand. This is where some of you are going to get messed up. Is this the same thing as this? And this is why math kind of sucks. I get it. Is this the same thing as that?
No.
No.
That was not very confident, Kelly. Why are you saying no?
Because if, say, like the x in both of them is 4, you would do 4 plus 2, and then that'd be 6, and you do that log. But if it's
So
if that's
this I
what
would do
we-
log of 6.
And then
And
for the second
here-
one, log of 4, and then whatever that is, plus 2.
Yes, and so that's different, right? The order of operations is different. That's why this one moves it left and right. This one moves it up and down because they are not the same. I know they look similar, but they're not the same because the order of operations is completely different in that. All right, next thing I need you to try is if I give you this. And I ask you to find the inverse. What does it mean to find the inverse? Come on, guys. We just talked about it at the beginning. Dominic, what does it mean to find the inverse?
Swap the x and y.
So first I'm going to make this become a y. And then perfect, like you said, this is going to become x equals 10 y to the y plus 1 power. Now, what's the next thing when we did the inverse? We just did this like last chapter. What's the next thing I have to do? I changed it to y, then I switched the x and the y, then what do I have to do?
Solve for y.
I have to make it say y equals, what's the problem?
Y is in the exponent. Y is an
It's
exponent.
in the power, and there's no way for me to bring it down, not in this form. So I go, hey, Mr. Martin taught me how to change this form. When something is no good in mathematics, we go, all right, that's okay. I can change the way this thing looks. So right here, this is called exponential form. We are going to change it to logarithmic form. So we're going to go log base 10. So really, I don't need to put any number here. X equals y plus 1. Notice the y is no longer in the exponent. Now it's down here where it's somewhere I can actually get to. I can isolate it now. All I have to do is minus 1, and we just talked about this. So this would be log base 10 x minus 1 equals y. So if I was making x and y chart for this, you would plug your x in here. You would actually take the log of it first, then minus 1, and that would be your y. This is different than this, which is what we just talked about. But I'm going to keep bringing it up to make sure you understand. They are not the same. Find the inverse. Trey, what's my first step?
You got to change the x to a y.
So there you go. What's the next step?
I don't know.
As soon as I hear the inverse, what do I need to do?
Find more.
Trying to give you hints.
I don't know. Find y. I know you got to do that.
Well, I can't. I already found y right now, but that's because I haven't actually done the inverse part. What does inverse mean, Trey? Switch. Someone help him out.
The x and y.
So now this is going to read as x equals log 7y plus 5. The inverse means you switch the x and y. Taylor, what's my next thing? What am I now going to try to do?
Solve for y.
So we want to make this sucker now say y equals. That's my whole next goal. So do I have some base? Do I have something right next to it? And do I have just an answer? Yes, which means this form is no good for me because I cannot get y isolated. So I'm going to change it to power form. And when I do that, I get 7x equals y plus 5. So sometimes log form is good. Sometimes exponential form is good. And now I just got to get rid of this guy. So I minus 5. Don't you think that's a division? So I minus 5, and I get 7 to the x minus 5 equals y, and there would be my inverse. All right, last one, and then I'm going to give you some to try on your own. R equals 12 times, 12 log a plus 1 plus 25. Now, what this is sometimes we are given equations, but we don't like the thing that they gave it to us in. So like distance equals rate times time. That should be a formula that you know from back in the day. Well, sometimes I want to know how long it's going to take me to get somewhere. And I know the distance and I know the rate. So we can actually manipulate this equation so that it actually says t equals, and all we do is divide by r, and what we're telling you is if you take the distance, you divide it by the rate that you're traveling at, we can tell you how much time is left. By the way, distance, let's call it in miles. My rate would be miles per hour, right? Not only do this, like these things cancel out and reduce to a different number, the miles cancel out, and that's why my time would be left in hours. All right, so I don't like this, the equation they gave me, they gave it to me in what this is called my revenue. And this is how much revenue I would generate depending on how much advertisement. So A stands for how much advertisement money I spend. R stands for how much revenue I'm going to gain with that much advertising, how much I spent in advertisement. So what I want to know is, wait, I want to have $10,000 in revenue. How much do I have to spend in advertisement? So what I'm trying to do is I want to make this say A equals. So what I do, especially when I was first learning this out, is I know I'm going to be working backwards. But before I can work backwards, it might be best to know what I would do if I was going forward. So let's pretend I knew A. I would do A plus 1 first. I would then take the log of that, right? This would become a number. I would then times it by 12, so that would be my third step. And then finally, I would add 25, and that would be my fourth step. So if I'm working backwards, trying to make this say A equals, I got to start at the end and do the opposite of things. So instead of adding 25, I would take 25 away. And that would turn into R minus 25 equals 12 log A plus 1. And I go, okay, I got rid of 4. Now let's see, how do I get rid of the third thing, which was times by 12? Oh, that's easy. I just divide everything by 12. And no, this doesn't turn into a certain number. It's you take the revenue minus 25 and then divide it by 12. And that should equal log A plus 1. And I go, oh, crap, I'm kind of stuck. I can't do anything else to get A by itself. So I go, okay, wait. This is base 10, even though they didn't write it. I understand that. And I go, you know what? Log form, you're not doing anything for me. So let's change it to power form, which would turn into 10 to this power. So this would be R minus 25 over 12 equals, and then whatever's this, which is A plus 1. And again, the final thing is I'm just trying to get A by itself. So I'm minus 1, and so 10 to the R minus 25 over 12 minus 1 equals A, which means if I told you R, you would take R and plug it in here, you would minus 25, you would then divide by 12, you would then take 10 and raise it to that power, and finally subtract 1 from that number, and boom, you've got A. Did that make sense? I appreciate the thumbs up. Let me know you understand it. All right. Here are some for you to try on your own. This is what your homework